So welcome everyone to Guidance Study Group Week 11 of Statistic 100. So as you guys know, these are the few last weeks of Statistic 100, and I hope everyone did well on the midterm exam last week. This week we're going to be working on confidence intervals and using it to identify if there's any difference between two means or two proportion, or if there is any to find the confidence intervals for a proportion. So confidence interval is identified as a statistical method to infer from sample to populations. So kind of like you have a samples and you're trying to run like later on if you go into statistic 200 is where you're going to learn things like identify this test statistic and try to test it from the sample and maybe infer something about the populations. Here it's just gonna end up at confidence interval. To get a confidence interval, there's a trade-off between the level of confidence and the precision of the interval. So say if you want the interval to capture like 99% of the populations, the interval has to be wider, and also the interval will be more precise if you have like sample size, a bigger sample size, then your standard deviation is going to be lower, and the interval that you identify is going to be more accurate and more likely to contain the population values. Another thing to notice is that the formula to calculate a confidence interval is based on the normal approximation. So when you want to use the normal approximation or the identifying formula, you need to check for independent trials and the sample size. For say things like a sample with categorical variable with a proportion. So P be the proportion. So you need NP and N multiply 1 minus P to be both bigger than 5. And usually the survey should be unbiased, or the trials are independent from one another. Now we have two pretty smaller part when it comes to the confidence intervals for proportion. And so if you want to find the confidence intervals for proportion with an unbiased survey, you have sample proportion be the population proportion plus or minus the sample error. For large random samples, a confidence interval for a population is given by sample proportion plus or minus z gram, with z be the multiplier number that comes from a normal curve and determines the level of confidence. So say if you have 95% confidence, you're going to have a corresponding z gram, and I remember it's at 1.96 or 2. And multiply the thing over here as the sample as the standard error, which is sample proportion, square root of sample proportion, multiply 1 minus sample proportion, or it's just square root of P multiply 1 minus P divided by N, as we learned before midterm 2. We also have the normal approximation must be checked. So to use this formula, as I mentioned in the previous slides, there are things that you have to check for independent trials and big enough samples. Empirical rule applies for 68% of the 98% of the population is going to be between the sample proportion plus or minus 1 standard error. 95% is going to be 2 standard error, and 99.7% is going to be within 3 standard error. And we're going to see that in the example. We also have the confidence interval for a sample mean. And again, the formula is very similar. Sample average is equal to population mean plus or minus random error. For large random samples, a confidence interval for population mean is given by sample mean plus or minus z star multiply standard error. And the standard error in this case is going to be found by standard deviation of a sample divided by n and take the square root of that. So the difference here is that in the previous part, when you're looking for the confidence interval for a sample proportion, we're having a categorical variable, and so the percentage of, say, the percentage of the population that containing a trait is represented by a proportion or a fraction of that. But here for a sample mean, it means we're talking about quantitative variable where we have samples contain of a bunch of numbers, and we're looking for standard deviation and sample error to calculate the confidence interval for sample mean. Again, Z star is a multiplier number that comes from a normal curve, and that goes along with the level of confidence. Again, check the normal approximation, and we have the empirical rules apply. Lastly, we have the confidence interval for the difference between sample proportions or means. And so when you have two samples are independent of one another, the standard error for a difference between two sample summaries is the square root of standard error in the first sample square and standard error in the second sample square. So it's just SE1 square plus SE2 square. And the confidence interval for the differences between the two population proportion is going to be the difference plus or minus Z star standard error for differences. When we're talking about this thing, there's another important concept is statistical significance and confidence interval. It's where you have, say, if you're looking for the two confidence interval of two different samples and they do not overlap, or if the confidence interval for the difference does not contain 0. So the confidence interval we're talking about here, there are two ways to look at it. If you look at two samples and you have two confidence interval, and if they don't overlap, then there's a statistical significant difference in the two population values. Or another way is that you find the confidence interval for the difference between the sample and identify if it contains 0 or not. If not, then there is also a significant difference within the population values of the two samples. Now let's go to the practice questions and problems to resolve it. Again, feel free to mute me anytime if you want to work on it on your own. Suppose 100 different polls were taken using the same methodology to construct 90% confidence interval for the proportion of voters. So 90% confidence interval and the sample size is 100 of voters who favor a tax increase to support the school district. Which of the following is true? Now A, about 90% of the polls will get a sample proportion that match the population proportion. B, about 90% of the poll will have a margin of error that cover the true proportion of voters favoring the tax increase. And about 90% of the polls will give a sample proportion within one standard deviation. Now let's look at this. Your sample size is 100, n equal 100, and p equal to 90. So NP is 5. NP is bigger than 5 because it's equal to, this is 0.9, it's 9. Is 90, and n 1 minus p is 10. Both of them are bigger than 5, so the normal approximation applies because the sample size is big enough. And so we also have the empirical rule applied. So C is not going to be right because we have the empirical say that 68% of the polls will give a sample proportion within one standard deviation and not 90%. And so this one is wrong. Now let's look at A and B. We're talking about a 90%. NP is not that. Oh, sorry. I make a mistake here when we're talking about a normal approximation. In these cases, we would try to see that the normal approximation will apply or not. But in this case, since probability of P is not given, so we're not going to take that into account, but we're just going to consider on the meaning of what exactly is confidence interval. So another way to think about confidence interval is that you're trying to identify an interval that will capture some percentage of the populations. So say if you pick a random value in the populations, there's 90% of the chance, or that is gonna fall into that interval. So say A here, about 90% of the polls will get a sample proportion that match the population proportion. Now we have the confidence interval is just an interval. You don't identify like a specific value for the sample proportion. So it's really hard to get 90% of the time that's gonna fall into that exact value. And that's not the meaning of confidence interval either. And so A is also not right. So the answer is going to be B. About 90% of the polls would have a margin of error that cover the true proportion of voters favoring the tax increase. And it's exactly the same way to phrase that 90% of the time, the true proportion is going to fall into that interval that we predict. Now let's go to question 2. 150 students attend the lectures of a statistics course. On the first day of class, the course instructor wants to estimate the average height of the student. And we have the sample size be, and we have the population. This is a population be 150 students. And the sample is going to be 9 students in the front row. So this is the sample. The average height of these is, so X star is 64 with the standard deviation of 3 inches. Would it be appropriate to use a formula sample plus or minus 2 SEM to make a 95% confidence statement? Well, let's think about it. When it's asking us, would it be appropriate? So it's basically asking us if we can use the empirical rule or not. And to do that, we need the normal approximation to apply. And that we think about the sample size, and if you have NP and N multiply 1 minus P bigger than 5. Here we don't have, but that one is the one for proportion. Here we have a mean. And so we look at the sample size, and is it a random sample? We're looking for the height of the entire class, but we only take the height from the 9th student at the front row. Now let's think about, it's not a very random sample because everyone is sitting at the front. It's more like a convenient sample, and so it decreased the degree of randomization in the experiment, and so it wouldn't be a very reliable sample, and especially when the sample size is so small. Not to mention the fact that most of the people in reality, when you think about it, most of the people sitting at the front all have a problem with their height or the ability to, look at the lecture and see clearly compared to when they're sitting at a distance. And so with a 9 students sitting at the front, it's not a random sample, and it's also are not independent trials because most of them are related to one another by height because they're facing the same problems. And so the answer for this is that this is not appropriate because this is not a random sample. And so that is question 2. The answer is B. C is partially right, that you have to use a different multiplier number, but it's only when the normal approximation applies. Here it doesn't even. So let's go to the third questions. Consider a random sample from a population. From which of the following conditions will the margin of error be the largest? Now, the margin of error is what we have. What is a sample value? It's going equal to the population value plus or minus margin of error. So the margin of error here, it contains Z star and the SEM that we have. So let's think about it. When you have the largest, it needs Z star multiply SEM to be maximum. And so when we think about each of them individually, SEM is square root of standard deviation divided by N. So if we want SEM to be large, we need the sample size to be small. And so it can only be A or B. So C and D are not right because of the bigger sample size. Now let's look at Z star. If you want margin of error to be maximum, Z star also have to be bigger. And so from the table of confidence level matching with the multiplier number, you have the larger the level of confidence, the larger G star is. And so the answer is A, when you have sample size equal to 100 and a confidence of 99%, which is higher confidence interval level. Question 4. All other things remaining constant. If the population size doubles from 5 to 10 millions, will a 90% confidence interval for the population mean get wider or narrower? Now let's look at we're looking about the mean. So we have population mean. See the sample mean. So we have this one is sample mean. The confidence interval for a population mean is sample mean plus or minus the standard deviation divided by n, with n be the sample size. Now if we look at here, the change of the population doesn't affect any factors in the sample, and so the confidence interval is not affected with the increase in the population size. And so the answer that we have is B, neither. Population size does not affect the confidence interval, and it is only affected by the sample size. Now, question 5. Suppose an unbiased random survey was conducted to find out what proportion of Central County residents intended to vote in the next non-presidential election. For which of the following confidence intervals would it be fair to conclude with high confidence that a majority of residents intend to vote in the next non-presidential election? So we're looking for the confidence interval that allowing us to conclude that majority of the residents intend to vote. So when we want the majority, in reality, if we think about the elections, the vote has to be more than half. And so if we look at the interval that we have here, C is the only one that matches because both ends of the intervals are above 50%. And so it allows us to make a conclusion that the majority of the residents intend to vote, because that statement means that say if it's in the majority of the time, a random person selected from Central County will be more than 50% likely to intend to vote. And so in that case, that's what we're looking for to make that conclusion. Now let's go to question 6. You're taking a class with a large number of students, so large populations. The professor notes that the midterm exam score will nearly bell-shaped, but doesn't tell you the mean. You take a random sample of 40 students and construct a 95% confidence for the mean exam score. Now the professor wants to give everyone 2 extra points on the exam. How will your confidence interval change? Now, if you think about it, you have a sample average plus or minus Z star multiply SEM. If you want to add 2 extra points on the exam, it means that all of the score is going to increase by 2, and therefore the mean is also going to increase by 2. Because if you have, say, add 2 for each of the score, like A plus 2 plus B plus 2, and then you have to divide it by 2. Basically, it's just, say you have the sample size be n. Basically, you have the total score plus 2 multiplied n divided by n. And so what you end up having is the all average that we have plus 2. So the average is going to increase by 2. But the standard deviation will not change, as we learned earlier, that it depends on all the values. But when you take standard deviation, it's the same way, because it just calculate the variability of the values from the mean, and the variability of all the values in the sample from the mean doesn't change with increasing 1 extra points, because the distance from the new mean is the same as the old one. So only the sample mean will increase, but the margin of error will stay the same. Now let's go to question 7. No matter what type of population value or combination of population values is being estimated using a confidence interval, what items should you be watching for in order to best assess the result? A. That the sample select represent the populations. That is true, especially that's what we're trying to look at when we're trying to conduct an unbiased survey. So it makes sure that we capture the same as much aspect of the population and not just any sample by confidence, no, by convenience or just for volunteer. B. That the confidence level is clearly stated. And that is also true when you need to identify a confidence interval for the population value. C. That any real differences for which the researchers imply a causal relationship came from a randomized experiment. Again, the thing with observational study is that it only allows us to make the best conclusion about association and not causal relation. And the causal relationship can only be drawn from a randomized experiment because it allows us to have a control group and the application of treatment based on random assignment. And so the answer is D, all of the above are correct. Now lastly, with question A. A wireless service takes a random sample of 400 of its customers and finds that 360 or 90% of them. So we have a sample of 400 and the proportion of 90%, which is 0.9, have a smartphone with both internet capabilities and a built-in camera. The standard error of the proportion is found to be about 0.015. So this is the standard error. SEM is 0.015 or 1.5%. A 95% confidence interval with a smartphone is, so the mean that we have is, the formula we have is 90% plus or minus Z star multiply SEM. Here we have SEM is 1.5% and Z star B2 for a 95% confidence interval. So we have 90% plus or minus 3%. So the answer is going to be B. So to find this 0.015, note the fact that we use a formula that we have, which is 0.9 multiplied 0.1 divided by 400. In this case, because we have a big enough sample, and also it's satisfying the conditions for NP and N multiply 1 minus P. Both of them are bigger than 5, so we can use a normal approximation here. And to use that formula, we calculate the standard error to be 0.015. So that is the end of my sections, and so next week we're gonna have the final week materials, and after that we're gonna, that coming Sunday we also have the review for the final exam. If you don't have any more questions, or if you want to email the questions later when you watch this video, feel free to send it to me and then I'll try to get back to you as soon as possible. Other than that, I'll end the sessions here and I'll see you guys next week. Have a great weekend.